Okay, we're into systems of equations and inequalities in Chapter 8. And I'm going to start out with an easy-to-solve system of equations. And all of these can be solved by elimination. So I'm not sure why they state that. There's also substitution. But eliminations, if you have to learn one way of solving eliminations, the way to go, because it'll work with anything. So when I look at my two equations, they're stacked on top of each other, and noticing that the positive y and the negative y will cancel, I'm just going to add each column. So for the x's, I get a 2x, the y's go away, and that's equal to 4 minus 12, which is negative 8. Let's finish solving for x. And now I'm just going to take that x, substitute it into one of the equations. And solve. Looks like y equals 8. You can check these if you like. I guess if I put that in and got an error, I'd probably go back and check. But you don't need to. They don't ask. On to example 2. I have a couple of choices here in order to eliminate either x or y. If I take the first equation and multiply it by a negative 3, I'll eliminate the x's. I'll get a negative 6x, and that'll cancel out with the positive 6x. I could also multiply by a negative 5. That would give me a positive 5y, but I'm going to go with a smaller number and just multiply by negative 3. So I get a negative 6x, negative 3 times negative y is positive 3y, and then I get a negative 6 on the other side of the equal sign. So when I stack and combine, I'll get negative 2y equals 2. Looks like y is equal to negative 1. And I can grab either equation. I usually work with the simplest, or the one that looks the simplest. Or if I don't even want to think about it, I'll just pick the first one. So I get 2x equals 1. So my two answers are x is 1/2 and y is negative 1. I'll make sure I wrote down the answer on the first one. Okay, on example 3, the first thing we're going to do, because there's all these fractions, and I sure don't want to work with those or want to work with them as little as possible, we're going to clear the fractions by multiplying each equation by a common denominator. Fractions, not factions. All right, just go away. Okay, so the common denominator of my first equation is going to be 10. And let's see what we get. I multiply 1/5 by 10. 5 goes into 10 twice. I'll get a 2x. I multiply, when I multiply 10 by negative 3/2, 2 goes into 10 5 times. I get a negative 15y, and then 10 times 40 is 40. On the second equation, I'm going to multiply everything by the common denominator of 6. So 3 goes into 6 twice. That leaves me with a negative 4x. 2 goes into 6 3 times plus 3y. And 3 goes into 6 twice, so 2 times negative 13 is negative 26. Okay, looking at my equations, if I multiply the first equation by a 2, I can cancel the y's. So I'm going to multiply that by 2, and that gives me 4x minus 30y equals 80. That'll allow me to cancel the x's. I get negative 27y equals 80 minus 26 is 54. And 27 goes into 54 twice. And that's a negative. All right, so I'm going to pick, I'm actually not going to pick the original equation. I'm going to pick the simplest of the two to solve for x. So I get negative 4x, I don't know if it's the simplest, plus 3 times negative 2 equals negative 26. And the reason I picked a change equation, I didn't want to work with fractions. I'm still avoiding the fractions. Negative 4x minus 6 equals 26. Negative 4x equals 32. And that gives me, hang on, let me stop this video and take a, yeah, that was not getting to the answer that I expected, and here's my error, I just dropped that negative. So let's try that again. Negative 26 plus 6 is negative 20. Divide that by 4, I'll get x equals negative 5. Nope, it's not a negative 5. Boy, when I start making errors, I just make them all over the place. All right, there's our answer, and that's enough for this video. See you on the next one.